Alright, so here are the answers to the problems, and they're pretty simple. It's like if you have this situation here, we know that the tangents are congruent, so we can set them equal to each other, right? So that's the same in this case, yeah. And then in these cases, we know that the tangent creates a 90-degree angle, so then we can use Pythagorean theorem here, there, and there. And then, yeah, so then that's it, right? And then what? So now we're on the next page. It's circumscribed polygons. When a polygon is circumscribed about a circle, all the sides of the polygon are tangent to the circle. So we have two examples here. This one has a hexagon circumscribed about the circle P. This one has a square circumscribed about the circle Q. And what does that mean? That means that this point here to this point there, F, is tangent to the circle P. And then this point here to E is tangent. So all of these sections of the polygon are tangent to the circle, right? Same thing here. So then this here is tangent to this, and then this section here is tangent to that section there, and so on as we work our way around the square. So using the property of tangents, we can solve problems. Because, for example, here in 3, we know that the triangle is circumscribed about circle O, so that means that AD is tangent, and also AF is also tangent. Since they're both tangent with an endpoint at the same point A, we learned in the previous page that this side is congruent to that side, right? And we also learned that this side here is congruent to that side, and that side there is congruent to that side. And so it's saying find the perimeter of ABC. Well, we just need to add them all up, right? So this here is 12, this section here is 6, section there is 8. And then we just go ahead and add them up. So it's going to be 12 plus 12 plus 6 plus 6 plus 8 plus 8 is equal to P, the perimeter. And then we'll add those up. So we get 24 plus 12 plus 16 is equal to P. And then I'll get P is equal to, so that's 30, 40, 52. And we're done, right? And then we'll come over here. It's the same thing, just different, right? A different kind of a polygon. But it's the same concept that HR is tangent to circle, whatever circle that is. And so is HS. And they're both tangent with an endpoint at the same point H, right? So that means that this section here is congruent to that section there. So that's 13. And then we have the same situation with point I. So SI is tangent, and so is IT, and they're both tangent to the same point I. And that means that they're both congruent. So that means this side is also 5. And that means that X is 13. Right? So we're supposed to here find X. We know X is 13. So I'm going to say X equals 13. And then we're also supposed to find the perimeter, right? And we're going to find the perimeter the same way that we did over here, where we'll add up all of the tangent segments. So we'll do 13 plus 13 plus 5 plus 5 plus 13 plus 13 plus 5 plus 5 is equal to P, the perimeter. So we'll add all those together, and we'll get P is equal to 13 times 4, so this is 26, 40, 52, 52 plus 20, 72. Right. And anyhow, we're going to be using the strategies to solve the rest of these problems down here.